determine what you need to find and define your variables. So that's really important, right? In the question is going to be, that's where your variables are hidden. So they'll ask you to, whatever you're looking for, that is your variable. And then we're going to create equations, and we're going to use a chart to help us create the equations. And so how do we use a chart? Well, let's read this question here. During part of a trip from Vancouver to Windsor, Senta's average driving speed was 4 kilometers faster than Jeff's. Senta and Jeff each drive 10 kilometers, or 10 hours. Altogether, they drive 1,900 kilometers. On average, how fast did each drive? Okay, so how do we set this up? It's a lot of information thrown at you, right? So let's split it up into two scenarios. What are the two scenarios that we have here? What's the question asking? Jeff's speed and Senta's speed. Okay, so that means we have two people, two scenarios, right? Two situations. We have Jeff, spelled with a G, and Senta. Shh, guys. Okay, so we're going to make a DRT chart with our two scenarios. So we have distance, one box, rate, and time. And we know D equals RT. That's our first step. Okay? Now, what we want to do is we're going to fill in our variables, define our variables, and fill them in the box of whatever we're looking for. So what are we looking for in this question? How fast each drive. So let's choose a variable for each of them. Okay, what's Jeff's speed going to be? X? Sure. So X represent Jeff's speed. And for Senta, we'll use, I'm going to use Y. P. It's random. Senta's speed. Okay. Now we're going to fill in a piece of information that we actually know. Come on. Okay, so what is a piece of information we already know? During part of the trip, let's read this again. From Vancouver to Windsor, Senta's average driving speed was 4 kilometers faster than Jeff's. Senta and Jeff each drive 10 kilometers. So we're looking for either a distance or time information that we can fill in. Although altogether they drive 1,900. So is there something that an actual number can go in one of the boxes? 10 hours. Yeah. So 10 goes in for our time. They each drove 10 hours. So once you have that, the third box, we're going to use the formula. Always use the formula. So the first box, we put in our variables. The second, we put in our number. And the third, we're going to use a formula to fill it in. Okay, so let's use the formula. Well, what's the formula that relates these guys? Distance equals rate times time. So rate times time, x times 10. How can you write that? 10x, and rate times time for Senta would be 10y. So now we need to relate the two boxes with information above that have variables. So is there a relationship between their distance? What does it say above about their distance? Together they drive 1,900. So what are we going to do with these two distances? We don't know if they're the same. We can't assume that they drove the same distance, right? But we know that together, what is together? What do we, in math, we put things together. Yes. You add them. Okay, so we're going to add their distances. What's Jeff's distance? 10x. What's Senta's distance? 10y equals 1,900. So there's one formula. There's our first one. Okay? Now our last formula, we need to find a relationship between the rate, because there's variables with the rate. What do they tell us about the rate? Is there something in here about the rate? Yes, guys. Okay, so listen very carefully to this. Senta's driving speed was 4 faster than Jeff. Okay, so who was faster? Santa. He was faster by 4. Okay, so second equation. Harkoman, did I ask you? Who's going faster? By how much? By 4. Okay, so if I want to relate x and y, we know Jeff's speed is x. We know Santa's speed is y. Hey, Matt. So you're saying y is equal to x plus 4. Would you all agree with this? That Santa's speed is equal to Jeff's speed plus 4. Yeah. There's our 2 equations. Okay, what does this set up nicely for? Substitution. Let's do it. Oh, you guys, should we do graphical? Some of you kind of like suck at the graphical. It's like you could do substitution, elimination in your sleep, but then all of a sudden you forgot how to like graph it. You okay? You really want to do substitution?
Yeah, let's just do substitution.
You want to do graphical? Okay, we're going to do graphical. Okay, so it's set up nicely for graphical because we already have y equals for one of them. So we just need to make y equals for the second one. It's okay. Do whatever. If you already did it, great. Okay? So solving for y, what's our first step on this equation here? 10x plus 10y equals 1900. Thank you. It works out nicely too. Because we have 10y equals negative 10x plus 1900. Then what? Divide by 10 or negative 10? Okay, we're getting y by itself. And the y is a positive 10. You were looking at the x. So y equals what? Negative x, thank you, sorry, plus 190. Okay, one equation, there's our y2, here's my y1. Okay, grab your graphing calculators. We are going to graph. So view, LED, attach it. Okay, y1 we said was x plus 4, right? Okay, x plus 4. The next one was negative x plus 190. Agreed? Okay, now let's reset our well, let's talk about our windows. What should we do with our windows? We need to, okay, our y-intercept is, one of the y-intercepts is how much? 190. So, and can we have a negative speed in not going into physics? No. Okay, so let's go to our windows, and we're going to go, I'm still set from yesterday, 0 to what? 200? I'm going to do 200 because we have 190 as one of the y-intercepts. Okay, and scale of 10. 0, 200, scale of a 10. Okay, graph it. What are we looking for? Intersection, right? If I ask you what the solution is, the solution to a system is the intersection point. Some of you were asking about that yesterday. Can't remember this class or the other class. What's the solution? See, we've been doing that this whole time. Okay, second trace. 5. Enter, enter, enter. If I asked you to write your windows, right, your solution needs to be within, you have to see the intersection in your windows. So if I asked you to write your windows, what I would need you to write for x would be 0 to 200, scale of, I think I used 10. And then y was 0 to 200, scale of 10. And the intersection was what? Does someone tell me? 93 and 97. Now this is why it's really important to define your variables. Whose speed was whose? X is G off. So Jeff's speed, we should write a sentence. I'm running out of room. Is 93 kilometers per hour, his average speed, and Santa's average speed is 97. Okay, now, graphically, checking your answer should be easy because it automatically stores X and Y, agreed? So you can check your work by going, quit out of here, 10X plus 10Y, blah, blah, blah. You know what I'm talking about? Okay, moving on. Let's try another one. 93 and 97. Okay, a small cruise boat took 3 hours to travel 36 kilometers down a river. Oh, what happened? Shoot. 1 second. Something happened. I'll open it again. Thought I picked over half the silver. Alright, read through the next question and start drawing the chart. This one's a little easier, actually. Well, yeah. Okay. Overtaking, this is the one, right? Good. An airplane traveling 600 kilometers per hour left Vancouver 13 and a half hours after steamship had sailed. If the plane overtook the ship in 1.5 hours, what was the speed of the steamship? So, what are the two scenarios? Plane and steamship. Okay. Airplane and ship. That's funny. Yeah, do you have a question? You're right. It's not. Forgive me. It's not at all a steamship. Forgive me. All right. So what are we looking for here? What is the speed of the steamship? Meaning what? That is my variable. So we're going to let that be X. Speed of ship. This one's actually pretty easy because we're looking for the speed of the ship. Do we know the speed of the plane? Yeah, we do this time. 600. Usually they would actually say, like, find both speeds, right? So this is a one variable question. What else do we know? Time. Okay, tell me how long the plane traveled for. 1.5 hours. Can you tell me how long the ship traveled for? Nope. Yes. 15 hours. Okay? Why did the plane ship travel for 15 hours? Well, the plane didn't leave, guys. So the plane didn't leave until 13 and a half hours later. So the plane left 13 and a half hours later. So it was delayed by 13.5 hours later. And then it traveled how long? 1.5 hours, meaning that the ship was traveling for how long? 15 hours. Does that make sense, guys? Or Steve, you okay? Okay, so how do we get our distance? Distance equals rate times time. All right, so what is the plane's distance? 600 times 1.5 is 900. What is the ship's? 15x. And what do we know about their distances? They're the same. So 900 is equal to 15x. Okay? The distance of the plane equals the distance of the ship. Because it's an overtaking problem, they start at the same spot, and when the plane overtakes the ship, they've traveled the same distance. This one's slower, this one leaves later, and then boom. Okay, so what is x equal to? 60? That's it. That one's pretty easy, hey? The ship's speed is, no, was it the ship? Yeah. That's a slow ship. Okay, turn the page. No, there's more. Draw currents. Sorry. Hey guys, do you need to go back to your seat? Okay. A small cruise boat took 3 hours to travel 36 kilometers down a river with the current. So if you ever taken a boat on a current before, right? If you're traveling upstream, what does that mean? Are you going slower or faster if you're going downstream? Going upstream? Upstream means you're going against the current. So it's actually the current is slowing you down. If you're going downstream, you're going with the current and you're speeding up, right? The current's pushing you and it's like, this is so easy. I love it. So a small cruise boat took 3 hours to travel 36 kilometers down a river with the current. On the return trip, it took 4 hours against the current. Find the speed of the current and the speed of the small cruise boat in still water. Okay, so what are my variables? Sure, x and y. What's x? Okay, now think about the question. Your variables come from the question. So x is going to be the speed of the boat in still water. Okay, look at the question, guys. Find the speed of the current and the speed of the boat in still water. Those are our two variables. Yeah, Jash. Okay, so x is the speed of the current. Of just the current. Okay, y would be the speed of what? Of the boat in still water. So that was if there's no current. Oh, that fan just turned on, eh? That's loud. So let's make our what are the two situations that they give us in the scenario here? Against and not against. So you're going down the river and up the river. Or with the current and then against current. Oh my gosh. That fan is loud. With and then against. Guys. Okay, DRT. Let's fill in some information. So let's fill in their rate because that's where our speeds or our variables are going to go, right? With the current, what's your speed going to be? Anyone want to take a stab at it? Yeah? Oh, you already got the answer? I think. We don't know. Unless you already worked. Did you already work it out? Yeah. Okay, so but yes, you're right. You're right. You're right. You're right. So we're going to use that in a second. Let's first instead, before we get to that, let's use our variables to represent it. Because we just solve for those variables, right? So if I just plug in 36, 3, and 12, then that doesn't help me solve my problem. Well, it kind of does. You want to try that? There's a few ways to solve this one, okay? So the one way is to plug in what we know. We know that a cruise boat took 3 hours to travel 36 kilometers, right? And so you got 36 divided by 3 is 12. Good. And it said that on the return trip, it took 4 hours to travel how far? 36 as well. So what was the rate going against? 9. Okay, so this doesn't help us. It maybe helps us, but it doesn't really help us yet with solving for our variables. Can we make an equation with these rates and with our variables here? Okay. So when you're traveling up the current, that's the same thing as your speed. What's the speed of the boat? What letter is that? Y. And then what do you do with the, do you add the current or subtract it if you're going with the current? So y plus x equals 12. Would you agree? Okay. And when you're going against the current, it's your speed in still water, which is what? Y. And then what do you do with your current if you're against it? Is it speeding you up or slowing you down? Slowing you down. So you're subtracting the current speed, and that will equal 9. Okay, this is set up nicely for what? Elimination. Good. So we can, our x's are opposite sign. Could we just go straight to adding? Yeah, let's do that. Y plus y is 2y. Our x's cancel, and we're left with 12 plus 9, 21. So divide both sides by 21, and we get y is 10.5 kilometers an hour. So then what's x? Well, we can use either equation. 10.5 plus x has to equal 12. So what does x equal? 1.5 if we subtract that over. So therefore, the speed of the current is which one? Is x. Good. 1.5 kilometers per hour. And the boat speed in still water is 10.5. There you go. It's a tough one. Okay, one more, and we'll call it a day. We'll do it quickly. Maybe I'll get you to try this one on your own. Josh drove. Are you still writing that? Sorry. Josh drove 1,245 kilometers from Edmonton to Vancouver. His total driving time was 16.5 hours. That was a mistake. His total driving time should be 15 hours. Can you change that? Sorry. Okay, his total driving time is 15 hours. He averaged 100 kilometers per hour on the highway and 75 kilometers per hour on the mountain roads. How much time was spent driving on the highways? So, what are our two situations here that they tell us information about? Highway and mountains. Okay. And D, R, T. What are we looking for? How much time was spent driving on the highways? Okay, so we're looking for time. So we know our variable is going to go in the time spot. So let's start filling in some information. What variable do you want to be time on the highway? X. Do we know any information about time on the mountain? Well, let's fill in some other stuff. Do we know distances? Do we know how much distance was on the highway and how much was on the mountain? No. Do we know rates? Yeah? Okay. What do we know about the rate? Highway was average, 100. A mountain was average, 75. So we're going to have to choose a variable for y. Because we don't know, we just know a total distance, we don't know how much was each. So or a distance for the mountain, or time. Sorry guys. We need a variable for the time driven on the mountain. So let's choose y. Okay? So what would be your distance now? Now that we've filled in 2 boxes, we use the formula to get the third. So highway distance would be 100x, rate times time, and mountain time, our distance would be 75y. So remember, we have 2 sets of boxes with variables, so we need to find a way to relate them and form those into an equation. Is there a way to relate that distance now? What do we know about the distance? Total distance was 1,245. So if it's a total, or together, 100x plus 75y equals 1,245. Okay, what do we know about the time? Because we have to relate the time now because it has variables. X plus y is 15. Okay, so do we want to leave it there? Do you know what to do from there? Or yeah? We're okay with solving this? Should we do it? Okay, what would you like to use? We did graphical. Should we do substitution? We haven't done a substitution. Okay, so let's rearrange for x or y. Y in the second equation. Okay, so in the second equation, getting y by itself, first step, subtract x. Y equals negative x plus 15. And now we're going to sub that where? Into the other equation. So wherever we see y in the other equation, we're now going to put negative x plus 15, right? So now that we have y equals, I replace the y for what y equals. Now, distributive law, what's 75 times negative x? Oh, you're already at this. 1,125 is 75 times 15. 100 minus 75 is 25x's, and subtracting 1,125 to the other side, we get 125. No, 120. Oh, this is an ugly answer. Darn. Okay, let's just add, is it a nice decimal at least? Okay, what is it? 4.8? Good. So x equals 4.8. And then finding y? 7, 1 or 2? Let's do 2. 4x plus, or x is 4.8, so 4.8 plus y equals 15. So what is y equal to? 10.2. Okay. Alrighty. So these are not easy though, hey? They're tough. This is as tough as it goes in Math 10C. Yeah, no, maybe earlier, harder. Well, that's good. Well, that's it. It's your last lesson. Done. Except for the homework. Okay? Now, I'd like to do a homework check tomorrow. Maybe on this stuff. Okay, what is your assignment? It is, let me just find it. Your assignment is page 651, numbers 5, 6, 7, and 9. Why don't you circle those right now? I'm going to turn this off. 5, 6, 7, and 9. Okay, 651, numbers 5, 6, 7, and 9. Okay. 5, 6, 7, and 9. Okay? So I'm just going to stop.